All right, we're going to talk about a strategy for integration. Remember, with derivatives, you were able to follow some rules, the chain rule, product rule, and quotient rule, to find the derivative. But as far as integration goes, it's not that simple. So all we have are strategies, and sometimes the strategies work and sometimes they don't. But you just try until something actually works. This is one of those strategies. This is called substitution. So first, let's talk about when you would even think about using integration by substitution. First of all, you would want to see if what you're taking the integral of, and I call that the integrand, if you see that the integrand has a function and its derivative in it, that's when you would want to use u-substitution. And so here's a description of what we're going to do. We're going to let the letter u, or the variable u, be the function. And based on what that function is, we're going to find du dx. So we're going to take the derivative of this function u with respect to x, and we're going to solve for du. If there are any constants that appear in the derivative that aren't in the question that you're trying to solve, then you're going to multiply or divide them out just to make du look more like what it does in the question. And then we are going to make substitutions so that all of your x's and dx's are replaced with u's and du's. And then we're just going to evaluate, okay, with respect to u instead of with respect to x. So now I have an antiderivative that's in terms of u, but obviously I want to get back in terms of x's. So I need to substitute back what u was equal to in terms of x so that I can actually answer the question. So that really the only way to do these is through examples, and I found some fairly good ones. You're just going to need to do a lot of these to get used to this process so that you can kind of see when to use it and how to use it. So the first example I have is the antiderivative of x squared times the sine of x cubed. Now you can see that x squared is kind of the derivative of x cubed, but we're missing a constant. That's okay if we're missing a constant, as long as I recognize that u is going to be the x cubed and x squared is going to show up somewhere in my du. So let u equal x cubed, and then to figure out the derivative of that, I'm going to say du dx is the derivative of what u was defined to be. So du dx is going to be 3x squared, and if I multiply by dx, I get that du is equal to 3x squared dx. The problem that I have is that my x squared shows up in the question, my dx shows up in the question, but that 3 does not. It's okay if a constant doesn't show up. I can simply multiply both sides by 1/3, and now I have x squared dx equaling 1/3 du. So what I'm going to do at this point is my x squared and my dx are going to be replaced with 1/3 du, and my x cubed is going to be replaced by simply u, so that the only variable I really have in my question is now u. So now I'm finding the antiderivative of 1/3 times the sine of u du. That's a lot easier to do because it's a much simpler function now. So the answer is negative 1/3 times the cosine of u plus c. And now I'm just one step away from being done. That variable u is something I made up, so I've got to substitute it back. So instead of it being negative 1/3 times the cosine of u, it's negative 1/3 times the cosine of x cubed plus c. Okay, I'm going to do 2 more examples, and that should be enough to kind of get the idea of what's going on here. If I look at this question, I've got the secant squared of the natural log of x over x. So remember, I'm looking for a function and its derivative in the same question. And the only thing that I see is ln x and 1 over x, natural log of x and 1 over x. 1 over x being the derivative of natural log of x. So the function is going to be natural log of x. Its derivative is 1 over x. And if I multiply by the dx, just to get du by itself, that was one of my steps, I get that du is 1 over x dx. Okay, and this looks good because there's no extra constant being multiplied or divided to throw me off. I've got 1 over x dx in my question, which I'm going to replace with du, and I've got natural log of x, which I'm going to replace with just u. So my function is secant squared u du. That I should know the antiderivative of. It's tan u plus c. All right, so if I make that replacement, replacing u with what I set it equal to, my answer is the tangent of the natural log of x plus c. And just like always, if you're not sure whether you got the right answer or not, you know how to take the derivative. If you take the derivative of your answer, you should get back to the original question. That should always work. And one last example, we are going to do e to the cosine x times sine x dx. All right, and so it's kind of hard to choose in this case because the derivative of sine is cosine and the derivative of cosine is negative sine. So I could do it either way, but what's really going to make up my mind here is the fact that I don't want du to be somewhere in an exponent. Du should never be in an exponent somewhere. So I'm going to let cosine x be my u. That way I can just make the e to the cosine x just e to the u. And my du dx is going to be negative sine x. The only problem that I have with this is that negative sign sitting out front. So if I change the sign of both sides, I get that du, or negative du, is sine x dx. So now everything that I want to replace can be replaced. My cosine x that's sitting right here will be replaced with u, and the sine x dx at the end will be replaced with negative du. And I can move stuff around so that it looks like negative e to the u du. I know the antiderivative of that. That is negative e to the u plus c. And then making that final substitution to get it back in terms of x, this is negative e to the cosine x plus c. And again, take the derivative of this and make sure you get back to the question. That's just a way of checking your answer to make sure that you're right. We'll do a lot of examples of these tomorrow, but feel free to ask me questions in the meantime, and I will see you tomorrow.